Okay, welcome back everyone. So last video we stopped with configuring site B. We've got a fully functional site B up to the internet. From previous videos we've got a fully functional site A also up to the internet. So it's time to look at connecting them together. Right before we do that, I wanted to take a peek at the switches, and let's just look at the switches in site B really quickly. So if we run the command show spanning tree, all right, we can see that it will show us all the instances of spanning tree that it knows about. So we have 4 VLANs defined on the switch. 100 or 1 is the default, so that's always going to be there. We've got VLAN 100, we've got VLAN 200, 300, and 400. Okay, so what happens with spanning tree out of the box is it's a per VLAN spanning tree essentially. So every VLAN that we have, there's going to be a separate instance of spanning tree that runs for that VLAN. So you can see that with the show spanning tree command. We can see that this is all the information regarding STP of VLAN 100. Okay, this is one of the key pieces we want to see. So I am on switch 1, okay, which this says that this switch or this bridge is the root of the spanning tree. Okay, so that's a good thing. It just so happened that it worked out that way for us. But if this switch was not the root, the only other switch in the environment is switch 2, which would make it the root. Okay, but that's kind of a funky flow from a layer 2 perspective. So you wouldn't want this switch 2 to be the root of the spanning tree, because why would you want to send ARPs and ARPs to switch 2 only to go back to switch 1 and out, from let's say PC1's perspective? It doesn't make sense to do that. So switch 1 really should be the root, which it turns out that it was. But what a good practice to do is, let's say our company is growing and they're going to acquire the 3rd floor and the 4th floor and more floors on the building. We might want to hard code switch 1 essentially to kind of be the root of the spanning tree. So any other subsequent switches that get connected don't overthrow that switch and become the root, because that can cause some weird traffic patterns, if you will, from a layer 2 perspective. So there's a nice macro command that Cisco introduced years and years and years ago, which essentially adjusts the priority to kind of guarantee that switch 1 will be the root of the spanning tree. So that command is spanning tree, VLAN, and then here you define your VLANs, okay? So if you wanted to just engulf everything, so do show VLAN brief. Yeah, 1 through 4094, okay? So that's what I was looking for. It took me a second. So if we want to just engulf everything, we can just say 1 through 4094. So if we do spanning tree, VLAN, see, it allows you to type a range. So it says enter the VLAN range, or you can just enter 1, 2, 3, VLAN, whatever you want. So we're going to say 1 through 4094, okay? And then this is where you adjust the forward time, the hello times, all the parameters of spanning tree. If you want to get into the business of tuning it, most people just set it and forget it, and they don't really care. Spanning tree is a very old protocol. It's tried and true. It just kind of works. But if you don't understand it and you don't know what it's doing, it could bite you in the butt. But in our case, we're going to say spanning tree for all VLANs on switch 1. We're just going to say that we want him to be the root, okay? And then you can say, if you have more than one switch, maybe you have we're going to get into this in subsequent videos, but you can have more than one switch and start running first hop redundancy protocols and things of that sort, where if one switch were to go into a reboot or die or something happens to it, the other switch takes over. So that's kind of what we're getting at with some primary secondary stuff. So in our case, we're going to say primary, okay? And you can see that we can end the command here. So what that does, so Just want to take a peek at what the priority was before. So it was 33. So let's just, we'll do 400, right? So if we take a peek at VLAN 400, the priority was 33,168. So see what it did here? So prior to me running the spanning tree VLAN 1 through 4094 root primary command, spanning tree had already determined that the priority for VLAN 400 was 33,168. Okay? So what the macro command does is it lowers that priority to force it to be the root. In our case, it was already the root, so we didn't see this behavior change. However, we did see the priority get adjusted accordingly so that we're effectively guaranteeing that this switch will never get overthrown as the root. So again, kind of a best practice to just something to keep in mind as you're expanding your layer 2 environment. Okay, so on with the WAN, right? So let's go over to router 1. Let's go ahead and close some of the stuff we don't need. Okay, so B router 1, right? Show IP interface brief. So we're going to be playing with ETH02. So, you know, we called one of our local ISPs that we know can give us MPLS WAN connectivity. We scheduled a time to get on the phone with them, and we're going to go ahead and get ourselves connected and establish that connection so that we can start taking advantage of it. We're going to take baby steps. We're going to start with just basic static routing. Typically, in an environment like with an MPLS, you're going to be running BGP, Border Gateway Protocol, between your device and the service provider's device. So this device would be called the customer edge, or the CPE, customer premise edge, and then the provider edge. So you typically make a peering, a BGP peering between the two devices, and you can then exchange routing information. And it makes, for large environments, it makes it a lot easier to manage what's going on. For our case, there's 2 sites, so it's not difficult to do static routing, but as you start to bolt sites onto your WAN, it becomes more of a challenge to manage that stuff. So we will come back and start to change this over to a protocol. That's probably coming quickly as far as the next couple videos goes. But let's just do static routing so you guys can see full connectivity between sites, and we can do some trace routes and verification. So what we'll do is we'll use the 192 scheme for the MPLS. So at the end of this video, I'll make a note of the IP scheme, and for the next video, it'll be documented on the topology. So we're going to say, okay, interface E02. All right, so let's just verify there's nothing on it, which there's not, and it's shut down, right? So let's do description. We'll say that, you know, let's just say this is a 1 gig as well. 1 gig MPLS. All right, we'll no shut it, and we'll give it an IP address of 192.168. Since this is site B and it's the scheme of 2, we'll stick with that. So we'll say we're 2.2. We'll make it a /30, okay, and we'll leave it as that. So we'll stop there. So there's not much going on here. It's mostly going to be the static route that makes this magic happen. So let's go to the MPLS router, or the provider edge in this case, right? We're just simulating a basic provider edge. So hostname MPLS, interface E02, no shut, description 1 gig MPLS to site B. IP address is going to be 192.168.2.1. Okay, and we'll just try to ping him. Okay, good. So we have connectivity to site B. So at this point, we're an ISP. That's our customer. So it's our responsibility to route their packets between their sites. Again, this is typically done through MPLS, BGP. I'm going to most likely make a video that dives into MPLS because it's a pretty cool technology, and it gives you guys an idea of what it looks like under the hood and how the service providers use, some pretty cool technology to kind of, between VRFs and some of the MPLS perks, they're actually allowed to like reuse IPs because it segments all the routing tables of their customers and they don't overlap. So it's pretty cool. So all we're going to do here is just create a couple static routes. So we're going to say IP route. We're going to build an IP route for site B. So 10.2.0.0, and that's going to go to the new IP address that we just configured between us and site B. 2.2. So basically, name site B subnets. Okay, so we're going to do the same thing for site A, but it'll be 1 dot and it's going to be 1 dot, right? Yeah. So we're going to just do that right now since we're right there. Do show IP route. So we've got a connected route, which is going over to site B, and then we've got a static route for 10.2. Why don't I see the other static route? That's weird. Let me configure the other interface as well. Actually, we gotta do site A as well anyway, right? So let's go into interface E01 description. Let me just mimic what I've got. E02 description 1 gig MPLS to site A, right? 192.168.1.1. Alright, and we'll no shut him. So we can see we've got our two interfaces with the two IPs. We can see do show interface descriptions. We can see that that's what they are. Do show run include route. We've got, it probably didn't inject it because it didn't have an IP on an interface yet. So now if I show IP route, yeah, that's what it was. So now we've got two static routes, one for site B, one for site A. So that looks good. Let's save him. Let's go over to router 1 on site A. And we're going to show IP interface brief. So in this case, we're using 02. Description. One gig MPLS. Oops. He's going to get 1.2/30, and we'll no shut him. Alright, so let's just do some basic pings. We didn't test that yet. 168.1.1. So let's see if we can ping our WAN provider. We can. Ping 192.168.2.1. We can ping him. Now, with any luck, honestly, no, there's one more piece to this puzzle. And again, this is a great demonstration of why static routes are just a nightmare. So we've built the static routes on the MPLS service provider side. However, we need to tell router 1 in each site about the opposite site, okay? So let's just check the routing table. So the routing table on site A has no idea how to reach 10.2, which is site B, right? If right now, if we were to try to ping 10.2, it would chuck that packet out the internet because it would actually match this route, which we don't want it to do, right? That's never going to work. So like watch, if I try to ping 10.0.11, it's going to be unreachable, which it is. If I trace route to 10.2.0.11, let me do the no IP domain lookup. See what it did there? I don't even need, I got it in here now. 200.0.11. So it chucked it out, just like I said, it chucked it out that gateway because it matched this. It matched the catch-all default route. So we don't want it to match that one. We need to create a more specific route that tells it, hey, you don't want to go out this interface, you want to go out this interface. So that's where the routing decisions start to come into play. And that's where protocols make your life so much easier, because all this stuff happens automatically and you don't need to worry about defining those static routes. So we're going to say IP route for 10.2.0.0/22. I almost did it again. 10.2.0.0/22. We're going to go out the MPLS 1.1. So name site B. Okay. Do show run include route. So you can see how the static routes start to add up, right? So we've got one going to the internet, which is the catch-all. So anything going to something we haven't defined, just go out the internet. Anything that's going to 10.1, which is our own subnets, go down to the inside to the switches. And anything going to 10.2, go over the MPLS, which is site B. So hopefully that makes sense. It's about as basic as it gets. But every time you add another exit point off a router, you would potentially have to build a route to go along with it, with static routing. So let's do the like route for router, the site B router. So show run include route. We can see we've only got the default to the internet. In this case, since we're doing router on a stick, we don't have the 10.route because it's not needed, right? So what we're going to do is we're going to paste in what we copied. This will be site A. This will be 2 dot, and this will be 1 dot. Okay. So if we go for the glory, of course I pick one that doesn't have an IP, right? So IP 10, I can't remember what he was in. Switch to PC3 was in VLAN 300. Okay, VLAN 300 PC3 10.1.2.13/24 10.1.2.1. Okay, let's go to PC3 on this side. He's already got his address. Perfect. Okay, that's good. Okay, so what we're going to try to do is we're going to try to ping so from site A PC3, we're going to try to ping site B PC3 and see if we have success or not. So we're going to try to ping 10.2.2.13 from site A. And there we go. It works. That's cool, right? So now if we trace to 10.2.2.13, wait, sorry. My bad. I'm an idiot. 10.2.2.13, we want to try to ping that from site A. Sorry. I pasted it in the wrong PC. Okay, that's better. So we still have success, right? So now we've got full connectivity from site A, PC3. So we go through our 2 switches up to the router, across the MPLS connection, over to site B's router, through the switches, down to PC3. So let's do a trace route to kind of see what that looks like. And you can see how the trace routes start to kind of grow in size, right? So let's walk through it together. So 10.1.2.1. So this PC sits on, what do we say, VLAN 10.1.2, VLAN 200 or 300, excuse me. It sits on VLAN 300. So it goes to its default gateway because it's trying to reach something that is beyond its gateway. So it chucks it to the gateway, which in this case is switch 1. Okay? Switch 1 has a route over VLAN 100 that goes to the router. So we can see that it chucks the packet to router 1, which over VLAN 100 in this case, 10.1.0, right? Router 1 has a static route for site B that we just created that points it to the MPLS. So it sends it to 192.168.1.1, which is the interface of the service provider MPLS router. Okay. He gets it, follows the route for site B, which says go to B's router 1, which is 2.2. Okay. And then he doesn't have the route because he has the connected router on a stick sub interfaces, so he already knows how to get to that PC because it's a connected gateway, so that's why it succeeds. So that, my friends, is an example of WAN site-to-site connectivity through MPLS. We've introduced VLANs, we've introduced all the stuff we've talked about so far, and we've now got a fully functional WAN environment between sites. So we can go many different directions from here to kind of further enhance this real life kind of lab environment. So I'm going to give a little thought to where we go next. I think maybe we start to talk about some routing protocols and maybe we go that way. Maybe after we cover routing protocols, we can introduce a data center into the mix. So let me think on it a little bit, and I'll catch you on the next video. Thanks.